Hi everyone, welcome to this video. In this video, we will be covering wide range of AWS services such as VPC, S3, EC2, DynamoDB, Redshift, and so on. So this video is created with the thought of covering the width of AWS services rather than depth. So I hope this video will give you an overview of the most commonly deployed services, what that service is, and their placement in the architecture, I would say. So I hope you will be able to learn something by the end of this video. So please do watch till the end and I would like to hear your feedback as well. So without wasting much time, let's start this video. So what we have done, we have created different categories and under each category, we will be covering some services. So let's say if we want to deploy some application, then we need to have a networking layer. On top of it, we can create our compute. We can have our storage where will store the data. We need to have some databases. Then security is another important aspect, authentication. So there are different categories that we have divided and we will be covering some of the services under each category. If I just go forward, so here what we are saying that for networking, we will be covering, let's say, VPC and there is another service called Route 53. Then for compute, we'll be covering EC2 instances, Lambda functions, some load balancers, auto scaling, and then we have databases. We'll cover RDS, relational database, NoSQL databases. We'll cover these things. And for application integration, because in case we want a multiple application to talk to each other, then we need to integrate those so that they can talk to each other asynchronously. Then we can use SQS or SNS. For authentication, we will be using IAM policies. Then storage, we have multiple storage of categories available in AWS. We'll be covering S3. Then we have EBS volumes or EFS. For security, we have KMS for encryption, and then we have secrets manager for storing the secrets. We have certificate manager. Then for management and governance, we have CloudTrail, CloudWatch, all these things we can see our billing also like and which service is consuming how much amount of money, so all these things we have. So basically we'll cover all these services one by one, and as we go forward we'll be creating an architecture where we will be placing these services. We'll make these services talk to each other and we'll try to demonstrate how in an architecture these services talk to each other and their placement as well. So before moving to the first service, that is VPC, I would request if you like this content, then do press the like button and also subscribe to this channel, as that will encourage me in making more such video and also that will extend the reach of this video as well. Thanks for that. So by the end of this series, we'll create overall architecture something like this, where we'll be adding the services, compute services, network, and all services here. So as we go through the services one by one, we'll keep on populating this architecture. So we will start from a blank AWS account and then we'll keep on adding the services. So let's move to the first service now. VPC or Virtual Private Cloud. Basically, this is a logically isolated virtual network. And here we can create subnets, routing, endpoint peering, or we can create NACLs, network access control list. So in simple terms, what is a VPC? So in order to create instances, we need to have our network created first, that is the underlying layer. So for creating network, AWS offers VPC. Here you can have your network created like, so let's say you have a CIDR block of 10.0.0.0/24. So you can use this CIDR block and create a VPC. Once you have the VPC created, then you can create multiple subnets in that VPC, and the CIDR ranges for subnet will be uh, created from your main VPC CIDR range. So you can create your routing as well. Then you can create endpoint, and then if you have another VPC in your account, you can do a peering between these. So all these things you can do. So basically VPC is the networking layer, and on top of it we create other resources. So here you can see that we have a VPC created, then there are multiple subnets created in this, and there is one device called Internet Gateway. So I'll just quickly touch upon this. Basically, if you want to communicate to the outside, then you need to have an Internet Gateway. That means if you want to access internet or if you want to communicate outside, then you need to have an Internet Gateway attached. If I remove this device from here, then you will not be able to communicate outside. So how, on a high level, this is Internet Gateway. So as I said, we will be creating an architecture, symbolic architecture, I would say, parallelly as we go through the services. So the first thing that we have created VPC, and we have created two subnets inside that VPC. And as I said, if you can create other resources inside the VPC, like you can create endpoints, and suppose this is another VPC, then you can do a peering between these VPC, and then you can route the traffic between these things. An important point I would like to highlight is that if you are doing a peering between two VPC, then the CIDR block should not be overlapping. That is an important point. So going to the next service, that is EC2 instances. So EC2 stands for Elastic Compute Cloud. And if I have to draw parallel, then it is more like a server or a virtual machine that we used to have in earlier. EC2 basically it is an on-demand scalable computing capacity. That means you can create instances on the fly. Suppose you need a couple of instances, then you can create those. You can decide your memory and CPU parameters, and you can create the instance. Since it is an on-demand feature, so your application deployment will be faster. So you need not to worry about the capacity planning a lot, and it also have a reduced cost because you do not have to procure the hardware in advance, and if you are not using the hardware up to the optimum capacity, then you are wasting your resources. So all these things are not there in cloud because you are paying for what you use. So if you are using the instances, let's say 8 hours a day, then you have to pay for that only. So that is the quite a good benefit for cloud. So here you can see that uh, here we have a VPC, then we have a subnet, and here we are creating a instance. So instance has an IP assigned to it. That IP is picked from the subnet range. And if you see there is a security group thing here, so I'll touch upon this as well. Basically, this is to control the traffic that will go in and out of the instance. So you need to define the inbound and outbound routes in order to communicate to the instance. So on a high level, this is the EC2 instance. And if I just go to the design, here you can see that we are creating two instances, instance 1 and instance 2. Both can have a different instance type. That means they can belong to different instance ranges. Like there are multiple instance types available like T2, T2 micro, medium. So depending upon your need, you can create an instance and use it. There are different purchase options like you can have on-demand instances, spot instances, reserved instances. So all these are there. So I will not go in much detail, but you can decide as per your requirement. Next service is EBS. EBS, or we call it Elastic Block Storage. So I'll give you some background. So we have just seen that what EC2 is. Suppose you are having some data in the EC2 instance. So what will happen to that data once your instance is terminated? So if you do not need that data, then it is fine. But if you need that data, then there should be a mechanism to have that data in a persistent way. So there is a storage that is attached to EC2. We call it ephemeral storage. And that storage is till the time your instance is running. Once your instance is stopped or terminated, your data will be lost. So in order to have the data in a persistent manner, you need to attach some storage to it that we call it EBS volumes. And it is easy to use high performance block storage. You can create and mount these volumes to your instances, and it is a dedicated block access for a single host. So once you store data in the EBS volume, that will remain, but again, it is depending upon the setting, but that can be persistent. So if you stop or terminate this instance and you do not wish to delete the EBS volume, then it will remain as it is. And next day, suppose you created a new EC2 instance, then you can attach this to this, and your EC2 instance will have access to the data that was previously created. So that is the purpose of EBS. It is a persistent storage. So you can create different types of EBS storage volumes. So there is SSD, solid state drive based, or hard disk drive based. So depending upon requirement, you can create any of these. You can attach to your instances and run your application. So if I just point this in our design that we are creating, so you can see that we have created two EBS volume. One is attached to each EC2 instance. So as I said, if we wish to terminate this instance as we do not need it, but we need this data, then we can keep this EBS volume and we can attach this to the first EC2 instance. So now this EC2 can have the data of both the EBS volume. So that is the good part of EBS. So the next service is EFS. So as you can see that we have attached EBS volume to EC2 instances. But now we have another service called EFS. So in order to not to confuse, basically this is an elastic file system. And first of all, this is a fully serverless elastic service. Here you are creating file systems that can be shared among compute instances and on-premises server. So the difference from EBS is that EBS you need to attach to EC2, but this EFS, it can be shared between instances and also the on-premises. So this is a file system that can be shared among instances, on-premises, and so on. And since it is serverless, so it automatically grows and shrinks as you add or remove files. Suppose today you added a lot of files, then the EFS size will grow, but you remove some files tomorrow, then the EFS file or EFS size will shrink and you will have that much only. So again, it is cost effective because you will be paying for what you are using. So here you can see that you can create EFS and it can be used with EC2 and other services like ECS, EKS, Kubernetes, Fargate, Lambda, and you can also mount on-premises servers. That is the very important point. Then you can test it and then you can move the data. All these things are there, but basically my point is to explain the EFS that it can be shared among the instances and on-premises as well. And it is a serverless service. So in the design, what we are creating, you can see that we have created a EFS and we have attached that to both of our EC2 instances. So both can access the data from here. So it's a file system. So this is how EFS will fit in the picture. So now moving to the next service, that is RDS. So if I just do a quick recap, now we have created some instances, we have some storage, but if you want to host an application, there is a high probability that we need to have some database as well. So RDS is the service that fulfills that thing. So it is a relational database service. So here you can create your own databases, and AWS offers different database engines such as MySQL, PostgreSQL, MariaDB, Oracle SQL, and some more. So from here you can easily set up, operate, and scale a relational database. So you can quickly create, let's say, one Oracle database or SQL server and attach or allow your EC2 instance to access that, read and write access. But with the databases, we need to perform a lot of additional activities as well. Suppose we have created earlier. If I talk about, we have to create one server, then we have to install some DB on top of it, then we have to take care of patching, we have to take care of security, monitoring, alerting. So all these things we have to take care separately in our data centers. But with cloud or AWS, I would say all these things are very easy to do. So you can create a relational database. You can set up security and compliance. You can set up data encryption. You can scale it. You can do automated patching and upgrades. You can set up monitoring and alerting. And most important, backup and recovery also can be set with just few clicks, I would say. So this saves a lot of time and you can focus your time in activities such as innovations. So here you can see that we have created two RDS instances and these can be different engine, like one can be Oracle, other can be MariaDB, let's say. And just point to highlight here is that we have created this in separate subnet. So in terms of creating this separate subnet, the main point is that we do not want our databases to be exposed to outside, and it is always recommended to have database in a separate subnet, or we have terms called here private subnet and public subnet. So let's say this is our public subnet and this is our private subnet. So what makes this public and private subnet is that if we attach, let's say, our internet gateway here, IGW, then this subnet can talk to outside. So this will be called as a public subnet. But since this subnet does not have any route to outside, so it is a private subnet. So it is recommended to host databases and all these things in private subnet so that these cannot be accessed from the outer world. So the next service is autoscaling. So what is autoscaling? I'll just tell you the problem statement first and then we can go towards the solution. So by now we have created, let's say, two instances and we have hosted our application on these. So let's say this instance goes down, then our application will be left with this only. And this can be a single point of failure because we have one running instance. And the other scenario is that we have application on two, but during business hours, these two instances are insufficient to handle the load. But the requirement is to have seven such instances. So what will we do? Either we have to spin up more instances or we have to take care of this single point of failure. So this is a very difficult situation to be in. So in order to solve this problem and reduce the manual effort of creating more instances and having a continuous eye on the failure of instances, the solution is auto scaling. So auto scaling helps you automatically adjust the capacity. So once you enable auto scaling, you can define the minimum capacity, that means minimum number of instances that you want. You can define the maximum capacity, that means the maximum number the auto scaling will happen up to that number, and the desired capacity, that is the ideal number of instances that you want them to run all the time. So here how it works, I'll touch upon that. So here you create an auto scaling group, and once suppose this instance goes down, then the auto scaling group will create a new instance using the launch template or launch configuration. So the using that it will launch a new instance. Basically in the launch template we have defined what instance type we want, all the instance related detail. So as soon as this goes down and auto scaling configuration is set, so it will start creating one more instance using that. So it is very easily and quickly set up and it maintains steady and predictable performance. So it is very useful in terms of managing the application and workload. So here you can see that we have set up auto scaling and currently two instances are running. Let's say for this thing we have set up minimum capacity as 2 and max as 5. So let's say if this our business hours going on and there's a quite a load on these instances, and we have set up our auto scaling configuration. Let's say it's on based on CPU or a scheduled scaling. Let's say at 8 a.m. the scaling should happen and we should have few more instances. So what it will do, it will create one more instance. And let's say the schedule ends at 5 p.m. So after 5 p.m. it will remove this. And another thing that can do is that suppose we are monitoring some metrics. Let's say the CPU is greater than something, then add more instances. And if CPU is less than that, then remove those instances. So this all things can be automatically done without any manual efforts via auto scaling. So it is a quite a beneficial service, I would say. So the next service is CloudWatch. So before I explain what CloudWatch is, I'll take a pause here. As this video is getting quite long, so I'll divide it into maybe two or three, and I'll add these as a part one, two, and three videos separately. And I hope you have understood like what services we have gone so far. And if you like the content, then do press the like button and also subscribe to this channel. Thanks for watching this video. I hope we'll see you in the next video.